Today we're going to talk about exponential transformations. We're going to see a lot of stuff that's similar from transformations with others, talking about horizontal shifts and vertical shifts. Just pay attention to where the locations of these are. And remember, we can always graph whenever we want to see different things. These are going to be listed in your springboard. This is something we haven't used all year. So if you would, look in your Canvas and see if we can pull up a springboard. First thing I want to start with is our transformation PowerPoint. We've seen this before, and I've added, you can see it's highlighted right here, this same transformation that we're going to be talking about today, laying right there. So on our transformation, here's what I do want you to notice. First of all, the A value, which is our vertical stretch or compression, still falls at the beginning of the function. And the horizontal is still inside of a parentheses. That is our B value. That's our horizontal stretch or compression. And then we talk about our shifts. It's the same thing. The shift inside is the H value. That's our horizontal shift. Emphasis right here. Notice that the sign inside is a negative because it does have an inverse behavior. We do have a little bit of a change because the B does not have an inverse of behavior, but the H does have an inverse behavior. So when you see a plus sign, it's actually going to move it to the left. Minus sign is actually going to move it to the right. And then the one we usually do pretty well on, and that is our vertical shift. The vertical shift is not up in the exponent. It's just added at the end. It's just going to move it up or down. Now, we are building this off of the parent function n of x. We are going to see some differences in this because there are infinite number of families of functions. There's only one of all the ones we've ever covered except for this one. The parent function is based on whatever the base is. So we have the double family, the triple family, quadruple family, and everything in between, 1/2, decimals. So we are going to see some different behavior on that, and we just have to recognize that when we have a base, it has nothing to do with the transformation, and it has everything to do with the family that have been in range. None of them. All right, this is straight out of your springboard book, so hopefully you can find this. If you would, take a look at this, and here's what I was talking about. This is the 1/2 family. So we are always going to go in 1/2. Since we do not have an A value, the family of this function, we'll do this one in blue, is going to go through 0, 1. Because remember, the old formula A, B, X, this one's A value is an understood 1. So this is going through the point 0, 1. And then this is going to have the half. It's a decaying function. So when we move over 1, it's going to be at 1/2. When we move over to 2, it's 1/4, 1/8, 1/16, and then we have that asymptote that's happening. And if we back up, we should have a doubling behavior. So instead of being at 1, it's going to be at 2. 2 will be at 4. 4 will be at 8. And then the next one will be off of the screen because it would take us to 16. So our graph of this function, a decaying function like this is the parent function of the 1/2 base. So it goes just like that. So we've already constructed these. On Friday. So now we're going to have a transformation. Now, this transformation is outside of the parentheses, which makes it vertical. And it is multiplication, which makes it a stretch. And what that means is all of the y values will now be 4 times as much as they were. So this value of 0, 1 will now be 0, 4. This value that was negative 1, 2 will now be negative 1, and then 4 times that will take us to 8. Negative 2, which was 4 times that will be 16, which is taking us off our screen here. And on the other hand, the 1/2 times 4 will take us to 2. The 1/2 times 2 will take us to 1, and then you see we're going to go times 4, and this is going to continue to asymptote again. It's just going to have a faster movement moving in. So this is called a vertical stretch by a factor of 4. And again, the 1/2 has nothing to do with the transformation. It is just the family that it is in. So the way we describe this, vertical stretch by a factor of 4. All right, let's take a look at some more. About the reflections don't change. This one again, we see that this is the tripling family. So the base is 3. Since there is no a value, this is going to cross through 0, 1. And from there on, everything's going to triple. So we move over 1, it's going to triple. So 1 will move up to 3. And then 3 will move us to 9. And that's going to take us actually off the screen just a little bit. And when we go back, it's going to be a 1/3 ratio. 1/3. So you see we've got this value asymptoting, just like that. Now the next part is actually 2 transformations. We have the 1/2 transformation, and then we also have the reflection. It actually, the 1/2 comes from the value here, and then the transformation comes from, the reflection comes from the negative sign. So I'm going to go ahead and take the 1/2 first, and then I will reflect it. So where this value is 1, it's now 1/2. Where this value was at 3, this is at 1.5. Where this value was at 9, half of that will be 4.5. And we can actually still stay on the screen here because 9 would be 27. Half of that actually is off the screen again. So this first half looks like this. And then we're going to take half of each of these solutions as well, and it's just going to asymptote a little sooner, never going to cross the line. So this function would look a little something like that. I'm going to go ahead and write the ordered pairs to these because this will help me reflect this. This was 1, 1.5. This was 2, 4.5. Then the other one was off the screen. This one was -1, -1 and 1/6. And then again, we just start to asymptote. So all we got to do is to reflect these is change the values of the y's. So this y was at 1, 1.5 will now be at 1, -1.5. The value of 2 that was at 4.5 will now be at -4.5. And that asymptoting we saw coming from the top will now, coming from the top will now come from the bottom. So our final function is going to look like this. The green function is what our final function will be. This was the tripling family, so the way we would describe this is a vertical. This one is a compression by a factor of 3. By a factor of 1/2. And a vertical reflection. And you could say across the x-axis. That's a phrase you need to get familiar with saying, but that's a little redundant because a vertical reflection is a reflection across the x-axis. But be prepared to hear either of those two. This one we talk. All right. Let's get the parent function and determine what these are. Without the graph room, what I'm going to do here is just basically describe what's happening. You don't need to graph these down yourself, but I will put these for you. So this is the doubling family, and again, it's going to cross through 0, 1. That's where it crosses if there is no a value, which we don't have here. And the doubling family would be over 1, and the value would be double to 2, double to 4, and then half. So we have this right here. So this is what our function resembles. Again, it's just kind of a rough draft, so you'll hopefully forgive me. This is taking place inside of a parentheses. Anything that's taking place inside of a parentheses is horizontal. And since it is addition subtraction, it is a shift. If this sounds familiar, it's because you were paying attention when we did transformations on other things. Anything inside of the parentheses is horizontal, adding or subtracting is shift. So this is a horizontal shift. And again, anything horizontal has a reverse behavior. So this one feels like we should be going left 3 because of the subtraction sign, but horizontals are always tricky. They do the inverse of what you think. So this is going to go right 3. So every value that we had on the previous one, 0, 1, will be shifted over 3 units. So it'll be sitting here. The 1, 2 will be shifted over 1, 2, 3 units sitting here. This one will be shifted over 1, 2, 3 units here. This one here, and then the asymptotes are generally happening just like that. So that's what my g of x function would look like. And this is the description. This is the description of it. I'm going to pause the video whenever we get to this, but I want you guys to tell me what's going to be happening with the h of x. Hopefully, you recognize that this is, again, inside a parenthesis, which makes it horizontal. Adding or subtracting makes it a shift. And it is a plus 2, so we do the inverse of that, which would be left 2. So again, from the parent function, we're just going to back up 2 units, and we'll be here. Back up 2 units, we will be here. Back up 2 units, we will be there. So it's the same graph. Same graph, it's just been shifted to the left 2 units. Last one, we will not graph. We are just going to talk these through. And one of the reasons I don't want to graph these is because the base is 10. The 10 base function is an extreme jump like this. But its behavior is easy to determine because we just have to follow all these rules. G of x is action taking place inside of the parentheses, which makes it horizontal. That action is adding or subtracting, which makes it a shift. And then this would be right 1 unit. Let's talk h. I'm going to pause it again, let you guys see if you can do it with no assistance. And we should have recognized this is a horizontal shift, left 3 units. It's problems because shifting it left or right does not change the domain or the first time we've long here. Now these we're going to draw the second, and then we will describe the first ones for the same reason. This is a base 10. Again, base 10 is an incredibly steep slope right there. So our first value would be at 0, 1, which is always true. Then it would be 1, 10, which is usually off the screen, but if not, 2, 100 is. So it's pretty hard to graph these, especially freehand. So we'll just take a look at what behavior is happening. Well, first of all, let's recognize this is the base 10 family. The 10 has nothing to do with transformations. It is just the family in which it's identified. So our first function, which is given to us, and then our second function. Well, we see that we have behavior happening outside of a parentheses. Remember, anything that happens outside of a parentheses is vertical. And since that behavior is adding or subtracting, it is a shift. And remember, verticals, there is no trick with them. Just do what you think they're supposed to do. This would be a vertical shift down 1. H of x, again, outside of a parentheses makes it vertical. Adding or subtracting makes it a shift. And it is a plus sign which makes it go up 3. We will take a look at the last one in a graph. First of all, let's graph the parent function. Well, the parent function of this one is the 1/3 function, which means it's decaying. Since it has no a value, we know it's going to cross at 0, 1. And then everything after that will be 1/3. 1/3, 1/3, 1/3. So we got a pretty quick asymptote mapping here. And on the other hand, when we back up, it's going to triple. So it's going to be at -1, 3. So -2 would be at triple that, 9, which is almost off the screen here. So this is the 1/3 family. Decaying function looks like that. Now the -2, all that's happening here is this function, instead of crossing at 0, 1, has been shifted down to, it's going to be crossing at -1. This function that was at 1, 3 will be shifted down 2 units and be sitting right here. This function that was at 2, 9 is now going to be sitting at -2, is now sitting at -2, 7. So our entire function that you saw at the top is now asymptoting just like this. Here's what I do want you to notice. We did not touch on this the other day when we were dealing with domain and range. We never shifted down. On this case, the range has actually changed. The domain, notice we didn't say anything on any change in the range. Our domain is all real numbers. So all real numbers, it is what it is on the all real numbers thing. The range, remember, usually deals with 0. Y, where y is greater than 0. Well, this one's been shifted down 2 units, so we can actually get lower than 0, and since it was down 2, our new range is -2. Our new range is -2. So this one's range, since it was shifted down 1, was a range of y where y is greater than -1. And the h of x would be y where y is greater than 3. And they're all greater thans because they were not reflected. Reflected is what makes a negative sign. All right, so let's take a look at this one. First thing we need to recognize, what family of function is this? Let's say, where is the f of x of this one? Hopefully you answered the tripling family, 3 base x. This actually has two horizontal transformations. It's going through 0, 1 because that's where it's supposed to go through. It's the tripling family, so we're going to triple these two numbers. Triple 3 actually takes me off the screen, but that's close enough, so we'll put it right there. And then backing up would be 1/3, 1/3, 1/3. So we've got our asymptote happening. This is our parent function right there. Just like that. Well, we got 2 shifts, and I don't care if you do these all at one time or one at a time. Remember, this is going to move us left 4, and that's going to move us up 1. So if you want to do that on all these points, you're welcome to do that. Left 1, 2, 3, 4, up 1. So this point is now there. This point going left 1, 2, 3, 4, up 1 would be there. So this point is now transferred to there. This one, which was already off the screen, would still be over 1, 2, 3, 4, up 1, so it would be transferred over there. Same thing here, this 1/3 over 1, 2, 3, 4, up 1. Whoops. Yeah, up 1. And then we start the asymptoting here. But the asymptote is at 1. I should not be going below that line. This should be like that. And you are still welcome to use your graphing calculator. But it's good to know what these are doing without. So let's talk domain. Domain, all real numbers. It's what it's going to be. Doesn't matter what you do, shift, anything like that. If it's a function of with exponential, it is domain of all real numbers. All right, the range. Well, the range is generally 0 because it's usually asymptoting at 0. But this one got shifted up 1. So instead of asymptoting at 0 like we're accustomed to, this one's going to asymptote at 1. So that would be our range. All right, I'm going to give you a head start on this one. I'll pause it and let you guys get a head start on me on this one. And then we'll come right back to it. Hopefully you recognize this is the 1/3 family. 1/3 family goes through here. It's going to asymptote just like this. As we back up, it's going to triple. So triple, triple, there we go. Here's what the parent function looks like. Asymptoting just like that. So this one has 2 transformations, one of which is a vertical stretch. Outside of the parentheses makes every value in it double. So this one's going to go from 1 to 2. This one's going to go from 3 to 6. And that one's going to go way off our screen. 2 times our value, that's a vertical shift. Same with these, but 2 times 1/3 is just 2/3. And then whatever this one was, again, we've got our asymptote breaking down just like that. So it's a much steeper movement to the left, and that's what our first transformation does for us. And then our last transformation moves everything down 4. So where this one was at 6, it's going to go down 1, 2, 3, 4 units, and it's going to be here. And where this one was at 2, it's going to go down 1, 2, 3, 4 units, and it's going to be right there. This one was at 2/3, down 1, 2, 3, 1, 2, 3, 4 units. It's going to be there. And now we are going to start to asymptote at that -4. So this function, shift this one down 4. It's way off the screen anyway. So here's what our line looks like. And it's asymptoting at -4. So you see the similarities, hopefully, to the old transformations that we were doing. A lot of the same behavior. This one, let's go ahead and do it. Domain, all real numbers. Range. Y is our function value. where y is greater than -4 because of the shift down. Give you a second to look at that actually. All right, here we go, 4 times family. The original one is going through here. I'm not going to draw the whole line. Instead, what I'm going to do is just put the plot the points, excuse me. 2 takes me way off the screen because 4 times 4 is 16. This would be a 1/4, boom, boom, boom. So that's what the parent function would look like. You can either stretch and then move, or you can shift and then stretch. It doesn't matter, whichever one you want to do. Personally, I like to deal with it right now, the stretch or compression. So here's what I'm going to do. All of my values I'm going to cut in half. Half of this, half of that. Half of 16 would put me at 8. Half of this would be an asymptote. So that's where after our 1/2 vertical compression, because it's between 0 and 1, it would look like that. That's taken care of. Next thing we're going to do is the shift right 4 units. So everything, 1, 2, 3, 4. This point is now over here. Let's go ahead and do the -2 while we're at it, right? Down 1, 1, 2 puts us here. This point right here, we're going right 1, 2, 3, 4, down 1, 2. It's right there. This point, it's going over 1, 2, 3, 4, down 1, 2. And that's what I'll be looking for, the key points. Make sure that you're asymptoting on the -2, this value here, down 1, excuse me, right, 1, 2, 1, 2, 3, 4, down 1, 2. So we are asymptoting on the x equal to y equal, excuse me, y equal to -2. Domain, all real numbers, as always. Range is always going to be whatever vertical shift you see. So if you don't see a vertical shift, it's 0. Y, where y is, in this case, greater than -2. On this one, we're not going to draw, we're just going to describe. You have a graph there. I would like for you to graph those so you have something to look back at, but I want to just make the descriptions. So here's what we're looking at. It's obviously part of the doubling family because the base is 2. So fight the temptation and want to do something with that 2. There's nothing to do. That's the family. So first off, left off the 5 there too. Let's take care of our shifts first of all. We have both. We got horizontal shifts. We have vertical shifts. Horizontal shift, remember, even though there is not a parentheses around this, it's understood. Since they're both in the exponents, it's that way. So that's our horizontal shift. It's a horizontal shift. -6 makes us think left, but remember, it's always the inverse. So we are right 6 units. The vertical shift, outside of the parentheses, does what it's supposed to. So +5 is actually up 5. So there's our horizontal and vertical shifts. Last thing we have here is the -3. Now, you cannot have a vertical. It is a vertical, and it is a stretch. but you cannot stretch something by a negative number. When you see the negative number, that's just a reflection on top of a stretch. So this is a vertical stretch by a factor of 3, not negative 3. Make sure you don't put the negative 3. And then the last thing is the vertical reflection. Domain, as always, all real numbers. Range, well, this one is a little different. We can actually look at this and see, oh, well, it's 5. But remember, we were reflected. We were shifted up, but then reflected down. So this function is going to have the doubling behavior, but it's going to be coming from the bottom. We don't even have to graph this to make this determination. We just know that the y value must be, in this case, less than 5 because it was shifted up 5 units. Graph that and take a look at it. A lot of you are going to want to use the domain and range. Find the domain and range with a graph. I prefer to use a graph to find the domain and range. If you've got your graphing calculator, why not use it? All right, I'm going to look at this one with you guys. I'm going to probably just stop the video. You're looking at this one, and then I want to talk with you guys on this. I'm going to pause it for myself and then just put the answers up here and leave them alone.